Consider the following statements with reference to sensible heating of air. First one is dry bulb temperature and wet bulb temperature increase. Second one is specific humidity remains constant. Third one is relative humidity decreases. Choose the correct answer by using the codes given below. Here the codes are all 1, 2 and 3 are true, and second one is 1 and 2 are true, 3 is false. Third one is 1 and 3 are true, 2 is false, and fourth option is 1, 2 and 3 are false. First consider a psychrometric chart and on which a sensible heating process. So this is the psychrometric chart of the coordinates, dry bulb temperature and specific humidity. So now consider a sensible heating process on the psychrometric chart, and it is represented by a horizontal line on the psychrometric. Let us say the process is from 1 to 2. Okay, here this is a sensible heating process. So on this process, if you consider the specific humidity, there is no change in specific humidity from 1 to 2 because this is a horizontal line and is perpendicular to the specific humidity axis. So that's why there is no change in specific humidity from 1 to 2. So here specific humidity remains constant. And coming to the wet bulb temperature, so wet bulb temperature comes from, just draw inclined lines from the 2 points up to the saturated line. So here, and from that line, wherever these inclined lines cut the saturated line, just draw a vertical line. So it gives wet bulb temperature. So here this is 1 and this is 2. So here also the wet bulb temperature increases from 1 to 2. So in sensible heating process, wet bulb temperature is increasing. So consider now the relative humidity. Here this is the saturated line, so which gives 100% relative humidity. So the remaining relative humidity lines are parallel to this line, so similar to these lines, so that, and this is a way of decreasing the relative humidity. Like this is, let us say this is 90% and 80% and 70% like that. So if you consider 1 and 2 process, here the relative humidity decreases from some value to some value, so that here relative humidity decreases. So in the correct options here, the given statements are dry bulb temperature and wet bulb temperature increase. So this is right, and specific humidity remains constant. This is right, and relative humidity decreases. This is also right. So all 1, 2 and 3 are true, and in the options the correct option is A. A is the right answer. For the system shown in the given figure, the moment of inertia of the weight W of the ball about the pivot is I naught. The natural frequency of the system given by, here omega n is equal to half pi Ka square minus Wb by I naught. The system will vibrate when options are A. B less than Ka square by W, B is equal to Ka square by W, B greater than Ka square by W, and the option D is A is equal to 0. So here the natural frequency already given by the equation 1 by 2 pi into root of K square minus Wb by naught. The system vibrates when omega n greater than 0. System vibrates when omega n greater than 0. That means here the equation given for omega n, that is natural frequency for the natural frequency equation is this one, and it should be greater than 0. That means root of Ka square minus Wb by I naught must be greater than 0 and is equal to Ka square minus Wb greater than 0, or Ka square greater than Wb, and which is equal to Ka square by Wb greater than 1, and which gives Ka square by w greater than b or b less than k square by w. So the system vibrates when b less than the k square by w, and in the option the right option is A. A is the right answer. B on rigid link, AB moves with respect to A with angular velocity omega radians per second. The total acceleration of B with respect to A will be equal to, here the options are vector sum of radial component and curvaceous component, vector difference of radial and tangential components, vector sum of radial and tangential components, here vector sum of tangential and curvaceous component. Consider a link which is moving with respect to A, AB and B is moving with respect to A. Let us say it is moving like this. So here for this component there are two components, one is tangential and another one is there is normal component or radial component. Here this is the acceleration due to radial, this is the radial component acceleration and this is the tangential component of acceleration. So here the sum gives the total acceleration of the B with respect to A. So here the acceleration of B is equal to sum of the vector sum of radial and tangential components. So that the correct answer is C. C is the right answer.